Here we are looking at the review for the Unit 5A test. So for 1 and 2, we need to distribute this 3x squared to all parts of this so that we can simplify it. So when I multiply this, I multiply my coefficients. So 3 times 4 is going to be 12. X squared times x squared gives me x to a power of 4. And then 3 times negative 5 will be minus 15 with x cubed. And 3x squared times 2 will be plus 6x squared. Number 2, 4y cubed times 2y is going to give me 8y cubed. 4y cubed times negative 3y squared. It's going to be minus 12y to a power of 5. 4y cubed times negative 1 minus 4y cubed. Sorry, this should be 8y to a power of 4. Because when I multiply those, I got to add those exponents. And then I can rearrange this to go from highest exponent down to lowest. So it'd be negative 12 y to a power of 5 plus 8y power of 4 minus 4y cubed. For 3 and 4, when you're adding or subtracting polynomials, you only add or subtract like terms. So I've got 3 n squareds minus another n squared. So 3 minus 1 is going to give me 2 n squared. Then I have just n's. So I have negative 17n minus 4n. Negative 17 minus 4 is going to give me negative 21n. And then I've got 5 minus negative 2. When I subtract a negative, I'm really adding. So it's plus 7. So here if I've got x squared minus 6x squared, it's going to be negative 5x squared. Negative x minus negative 2x. Again, when I subtract a negative, I'm really adding, so it's negative x plus 2x to give me plus x. And then 3 minus 7 give me negative 4. So it's only when you're adding and subtracting that you only add and subtract the like terms. For 5 and 6, we're multiplying these, so I need to distribute to all parts. So I need to take this 4x to the 5x squared. So 4 times 5 is going to give me 20. X times x squared, x cubed. And 4x times 2x plus 8x squared, and 4x times negative 9 minus 36x. Then I need to do the same with this second term. So negative 3 times 5x squared, so minus 15x squared, minus 6x, negative 3 times negative 9 is going to be plus 27. And then I combine up all my like terms. So I have 20x cubed. I have 8x squared minus 15x squared. So minus 7 x squared, negative 36x minus 6x, so minus 42x, and then plus 27. So here's the same process. Negative 2x times 3x squared, going to give me negative 6x cubed. Negative 2x times negative 4x plus 8x squared. Negative 2x times negative 2 plus 4x. 3 times 3x squared plus 9x squared. 3 times negative 4x minus 12x. 3 times negative 2 minus 6. So combine like terms, you have negative 6x cubed. Here I've got 8x squareds plus 9 more x squareds, so plus 17x squared. Then I have 4x minus 12x, so minus 8x. Leave me just with the minus 6 that I haven't taken care of. When you are determining the degree of a polynomial, if it is in standard form, where you have each of your terms laid out, you look for any one term that has the highest degree. So there, my highest exponent is 5, so my degree is 5. When you have it in factored form, where you have the factor with an exponent, another factor with an exponent, another factor with an exponent, on and on and on, that is when you add your exponents together. So 3 plus 2 plus 1, even though it's not written there, is 6. When you have multiple variables, all in a single term, because there's no addition or subtraction here, you also add those exponents together. So 4 plus 8 is 12, plus 3 is 15. When you are sketching a graph, the first thing you want to do is identify where your zeros are. So I have a 0. If I have just x, that's a 0 at 0. X minus 1, if I solve that for 0, my 0 is at positive 1. And x plus 5 gives me a 0 at negative 5. So now that I know where the zeros are, I need to pay attention to what my leading coefficient is. If it is negative, that tells me on the right side it ends going down. Now I can follow, I know I go to that 0. When I have that 0, it's a multiplicity of 1, so it crosses right through. I have to turn back around, that way I can get to the 0 here. It also has an exponent of 1, so it crosses right through. And at some point I'm going to need to make a turn back up to go there. This is an exponent of 3 on it, so that means it's going to twist. So it gets close to it, lingers there for a while, and then carries on. So it looks like that. For number 11, it's the same process. I have a 0 at 0. This 2 in front of it doesn't mean anything. My other factor, x plus 3, means I have a 0 at negative 3. And then x minus 2 means I have a 0 at positive 2. My leading coefficient is positive, which means it ends going up on the right. So as I come here, this is a multiplicity of 3, which means it's going to twist through there. It's got to come back up so that I can hit my 0 at 0, which has a multiplicity of 2, which tells me it's going to hit there and bounce back. So that could be your touch, bounce, tangent, the look of a quadratic, however you have it. And then for my 0 of -3 coming from this factor, it has an exponent of 2, so it also is going to bounce back down. For number 12. So this 0 is at -2, this 0 is at 4, this 0 is at 5. So I'm going to put those zeros out here. I have a positive leading coefficient, so on the right side, I know it's going to go up. At 5, it has an exponent of 1, so it crosses right through. It's got to come back up so I can get to this 0 at 4, which has an exponent of 3, so a multiplicity of 3, making it twist through there. Then it doesn't come back down until -2. That has an exponent of 3, so it's another twist through that point. So our graph looks like that. We're factoring using our sums and differences of cubes. We need to remember that we're trying to find what cubed and what cubed. So x cubed, that means my a value is going to be x. 125 means my b value is going to be 5. And then, so I have x 5, x squared, 5x, and 25, following my a squared, b squared. And to figure out my operators that go between them is SOAP. So since I started with addition, this first one needs to be the same, so it needs to be plus. This next one needs to be opposite, so since I started with addition, it needs to be subtraction. And this last one, it doesn't matter what I started with, it's always plus. For 14, before I do this sum or difference of cubes, I look for a greatest common factor. I can pull a y out, leave me with y cubed minus 8, meaning my a value is y and my b value is 2. So I've got y minus 2, minus because I started with subtraction, y squared plus 2y plus 4, but I can't forget this y that I pulled out originally. That needs to come down and still be part of this factor, if it all factored out. For 15, it's okay that the variable isn't in front. I can have the variable behind. So my a value is 4, and my b value is x. So I've got 4 plus x, 16 minus 4x plus x squared. looking at 16, my a value is x. My b value, 27 is a perfect cube, and y cubed, also a perfect cube. So I can keep that all together, and my b value is 3y, meaning I have x plus, because I started with plus, 3y, then x squared minus 3xy, plus, when I square 3y, I need to square both the 3 and the y, so 9y squared. For here, again, I want to look for a greatest common factor, something that both of these have in common. So I can pull a 2x out, giving me 8x cubed minus 27. So my a value would be 2x, and my b value, cube root of 27, is 3. So I've got 2x minus 3, the minus because I started with subtraction. And then when I square this a, it becomes 4x squared, plus, because it's the opposite of what I started with, so plus 6x, because I do 2x times 3, and then plus 9. And just like in 14, I can't forget that 2x that was in front that I factored out from a greatest common factor needs to stay out in front. 18, again, I have a greatest common factor that I pull out first. So I have 3z that I pull out, leaving me with z cubed minus 125, meaning my a is z and my b is 5. So I've got z minus 5, z squared plus 5z plus 25, and that 3z that was out in front that I factored out as a greatest common factor still needs to stay out front. If you've got 4 terms, that's a good sign that you're going to be factoring by grouping. Anytime you factor by grouping, you still want to look for a greatest common factor if there is one. Here, I don't have one, so what I do, I group my first 2 together. I look, what can I pull out from both of those? I can pull out a 2x squared, leaving me with x plus 2. And with this grouping of the second one, negative 7x and negative 14, I can pull out a negative 7, leaving me with x plus 2. One of my factors is what I pulled out, 2x squared minus 7. The other factor is what was remaining. Both of those are the same as they should be when you factor by grouping. So x plus 2. Looking at number 20. Put these ones together, and I can pull out an x squared from that, leaving me with x plus 3. With these ones, I can pull out a negative 4, leaving me with x plus 3. So one of them is what I pulled out, x squared minus 4. The other one is what was remaining. Both of those are the same. X plus 3. However, x squared minus 4, this is a difference of squares because x squared is a perfect square and 4 is a perfect square. This part factors further as x plus 2, x minus 2. So if that factored further and it wants me to factor it completely, I need to factor that all the way down, not leaving it as x squared minus 4. I need to factor it out as the x plus 2, x minus 2, and then I still bring that factor that I had pulled out already of x plus 3. Again, I'm grouping these ones, these first two together. I look for a greatest common between those. So I can pull out 4x squared, leaving me with x plus 4. Both of these here are divisible by -9, so I pull out -9, leaving me with x plus 4. So one of my factors is what I pulled out, 4x squared minus 9. The other factor is what was left over. Both of those are x plus 4. This is another situation, just like 20, where 4x squared, that is a perfect square, and 9 is a perfect square. So this also factors further. It would be 2x plus 3 and 2x minus 3. And then I still had that x plus 4 factor that's going to come down. So while this is correctly factored, it is not factored completely. This is where we would be factored completely, much like we have in 20. This is factored completely. These ones, yes, are factored, but not completely. (22), I'm grouping these ones. These first two, I can pull out an x cubed, leaving me with x minus 13. Both of these, I can pull out a 3, leaving me with x minus 13. So one factor is what I pulled out, x cubed plus 3. The other factor is what I had remaining. Both of those are x minus 13. X cubed plus 3, those are not perfect cubes, so this is not a sum of cubes. This is it fully factored. Looking at 23, here, I'm able to pull out an x cubed from both of these, leaving me with x minus 2. For both of those, I'm able to pull out a -3, leaving me with x minus 2. One of my factors is what I factored out from each of those, so x cubed minus 3. The other factor was what had remained, x minus 2. And again, this is not a difference of cubes, so this is it fully factored. For 24, both of those, I'm able to pull out a 9x squared, leaving me with x plus 2. with both of these, I'm able to pull out a negative 49, leaving me with x plus 2. One of my factors is what I pulled out, 9x squared minus 49. The other factor is what I had remaining, x plus 2. This is one more example of when after factoring by grouping, I'm still left with a difference of squares because 9 is a perfect square and 49 is a perfect square. So that is going to further factor as 3x plus 7, 3x minus 7, and then I need to bring that other factor, x plus 2, down with it. Okay, 25 and 26, it gives us some information about our polynomial, and it wants us to write the equation for it. So I have a double root at negative 3. The factor that would give me a 0 at negative 3 would be x plus 3. If it's a double root, that means it has an exponent of 2. I have a single root at 7. The factor that would give me a root at positive 7 would be x minus 7. A single root just has an exponent of 1. You don't have to write a 1 there. I'm just writing it there so that we can remember that it has 1. A triple root at 0, any root that you have at 0 is just x. The triple means that it's going to have an exponent of 3 on there. And then I have a double root at 6. The factor that would give me a 0 of 6, of positive 6, would be x minus 6. The double root means a power of 2. And then it tells me that my leading coefficient is negative 3. So in front of all of this, there needs to be a negative 3. The order you have your factors written could be changed around. This x cubed could be up in front here. It could be there. Any of them could be mixed around, just as long as I have each of those that are in different colors is together in its factor. The degree, to figure out my degree, this is in factored form, so I add all these numbers up. So 2 plus 3 plus 1 plus 2, so that's going to be 8, which is an even degree. My end behaviors, because my leading coefficient is negative, that tells me as x goes to positive infinity, as x moves right, my graph is going down to negative infinity. Because my degree is even, that tells me that my end behaviors both need to be the same. So if this one was going to negative infinity, the other one also needs to go to negative infinity. That's because it was even, that they both go the same direction. Okay. Next one, I have zeros at 4 with a multiplicity of 2. So to get a 0 of positive 4, that factor is going to be x minus 4. A multiplicity of 2 means I have a power of 2 on that. Another 0 is at -3 with a multiplicity of 1. To get a 0 of -3, the factor would need to be x plus 3 with a multiplicity of 1, meaning an exponent of 1, which again, you do not have to write there. So if you don't want to write it, you don't need it. We then have a 0 at 1 with a multiplicity of 4. To get a 0 at positive 1, that factor is going to be x minus 1. We haven't talked a whole lot about multiplicities greater than 3, but if a multiplicity of 4, that just means my exponent on that needs to be a 4. And my leading coefficient is 8. So in front of all of this, there is an 8. The degree here, I have 4 plus 1 plus 2. So my degree is 7, which is an odd degree. Because my leading coefficient is positive, as x goes to positive infinity, my y values also go up to positive infinity. Because my degree is odd, these end behaviors must be opposite. So if this one went to positive infinity, my other end behavior has to go to negative infinity. So looking at 27, we're analyzing this graph. Because my end behaviors go in different directions, my degree has to be odd. The sign of my leading coefficient, I look to the right side, it is going down, therefore my leading coefficient has to be negative. I can look at the graph to figure these ones out. As x goes to negative infinity, as it moves left, my graph is going up to positive infinity. As it moves right, my graph is going down to negative infinity. My y-intercept is where it crosses the y-axis. My y-intercept is at the point 0, -3. My y-intercept is a point. I have a local maximum here. The local maximum of 0, because that's the highest point that it gets to, and it happens at x equals 2. I have a local minimum, a low point, right there. The lowest it goes down to is -4, and it happens when x equals -1. Increasing interval, that's where it's going up as I move right. So that is right here. That it is moving up. When I'm talking these increasing and decreasing intervals, I only care about the x values. So the x value here is -1, and the x value here is 2. So I'm increasing from -1 to 2. Decreasing is when it goes down, moving from left to right. Again, I'm talking about x values, so it's negative infinity to -1. And also, so I use the union, 2 to positive infinity. Because again, I'm talking the x values, that's my left and right values. To find out my zeros, I have a 0 here at -3. The factor that would give me that 0 would be x plus 3. Its multiplicity, it goes right through it, so it has a multiplicity of 1. That behavior, we have a couple of different words. We have cross, or we have linear. I have another one here at 2. So the factor there would be x minus 2. it hits it and goes back the other way, so that is a multiplicity of 2. So that behavior, we have a few words for that. It could either be bounce, it could be touch, you could have seen quadratic, or you could have seen tangent. All are the same thing where it hits it and goes back the other direction. So for 28, again, both of these arrows are going in opposite directions, so that my degree has to be odd. The sign of my leading coefficient, that's looking to the right, it's going up, so that needs to be positive. Filling this out, as it moves to the left, it's going down to negative infinity. As my graph goes off to the right, it's going up to positive infinity. My y-intercept is where it crosses the y-axis, so it's at the point 0, -2. I have a local maximum here. That maximum, the highest it goes to is 2, and it happens at x equals -3. I have a local minimum, a low point, right here. The lowest it goes down to is -4, and it happens when x equals 2. My increasing intervals, so I'm coming up this whole time from negative infinity to -3, and also from 2 to infinity. So I use that union from 2 to infinity. My decreasing interval right here from -3 to 2. The zeros that I have a 0 here at -5. So that factor would be x plus 5. It crosses right through, so that is a multiplicity of 1. The behavior, I'm just going to write cross. Next 0 I have is at -1. So that factor would be x plus 1. It goes right through, so that's a multiplicity of 1. So that behavior again just crosses right through. My next 0 is at 4. So I have a factor of x minus 4. Passes right through it, so it's a multiplicity of 1. So again, it crosses. Something that I forgot on 27, which I'm seeing as the same here on 28, is to write the equation for this. So I'm going to jump back to 27 and do that first. I know my leading coefficient has to be negative. It's going to be y equals negative. And then leaving it in factored form is just using these factors that I already found. X plus 3, a multiplicity of 1 means it has an exponent of 1. You don't have to write that exponent there if it's 1. The other factor I have is x minus 2. It has a multiplicity of 2, meaning I need to have an exponent of 2 on that. For this one, I've got y equals my leading coefficient. My leading coefficient is positive, so I don't need to put a negative in front of here, but I just need to put my factors out. I've got x plus 5. That's a multiplicity of 1, so it'd be an exponent of 1, which you don't need to write because it's just given that it's there. My next factor is x plus 1, also a multiplicity of 1. Then x minus 4, also with a multiplicity of 1. So there would be that equation for this graph. My arrows are going in opposite directions, so this is an odd degree. The sign of my leading coefficient, as it goes right, it's going down, so it needs to be negative. This one's going to be going to positive infinity. This one's going to negative infinity. My y-intercept happens right here at -2, so it's at the point 0, -2. Now it's wanting the ordered pairs for my local maximums. So I have a local maximum right here, and a local maximum right there. This local maximum, fairly easy to see where that point is. It's at -3, 5. This local maximum, it's not exactly on a grid point, so we're gonna have to give a rough estimate. We're gonna say that it's about 6.5 and 1.5. Okay, the ordered pair for my local minimums, I have a local minimum here and another local minimum right here. This one, pretty easy to see. It's at -5, 0. This one, once again, we're gonna have to give rough points, and we're gonna say that it's at 0.5, -2.5. I'm just saying that because it looks to be close to the middle of those areas. So increasing is when it's going up. So I'm going up here. And even though this flattens out here at 4, this is all one increasing interval. So I have 2 increasing intervals. So I've got from -5 to -3. And also, using that minimum point that I said was 0.5 to this maximum point that I said was 6.5. My decreasing intervals would be here, here, and there. So I have 3 decreasing intervals going from -infinity to -5, and also from -3 to 0.5, and also from 6.5 to infinity. The zeros I've got the 0 here at -5. The factor for that would be x plus 5. It hits it and bounces back the other way. Therefore, it's a multiplicity of 2 with a bounce or touch or quadratic behavior. My next 0 I have is right here at -1, making that factor x plus 1. It crosses right through, so that's a multiplicity of 1. Let me say that cross. My next 0 that I have happens here at 4. So the factor for that would be x minus 4. It stays there for a little bit before passing through. That's a multiplicity of 3, or a twist behavior. Then I have another 0 at 7, which the factor would be x minus 7. That's a multiplicity of 1. It just crosses right through. Because my leading coefficient is negative, I need to make sure that I have a negative at the front of this. And then I've got x plus 5 with a multiplicity of 2, meaning I need to have it squared. X plus 1, multiplicity of 1, so I don't need to write an exponent on there. If I wrote an exponent of 1 on there, that'd be fine. X minus 4, multiplicity of 3, I need a cube on there. And then x minus 7, multiplicity of 1, so I don't have to write a number on there. Here, both of my arrows go the same direction, therefore my degree is even. Leading coefficient, it's going down to the right, so it needs to be negative. So both of these are going to negative infinity. My y-intercept happens here at the point 0, 1. I have two local maximums here and there. So this one, we're going to say happens at negative 2, and we'll say 3.5. This one we're going to say happens at 5.5, and we'll call it 6.75 is that ordered pair. Local minimum, I only have one that happens right there. So it's at the point 1, 0. I'm increasing from negative infinity to negative 2. And also from 1 to 5.5. I'm decreasing from negative 2 to 1. And also from 5.5 to infinity. Last thing I need to do here are my zeros. I've got a 0 of negative 6, making that factor x plus 6. It twists through there, so it has a multiplicity of 3 with a twist behavior. Next 0 happens at 1, making that factor x minus 1. It hits it and bounces back, so it's a multiplicity of 2 with a bounce. My last 0 happens at 8, so that factor is going to be x minus 8. It just crosses right through, so it's a multiplicity of 1. So when I write this equation, my leading coefficient's negative, so it's y equals negative x plus 6 cubed, x minus 1 squared, x minus 8.